I'm Lamiae Dridri. I will be presenting to you mortality prediction in ICUs, intensive care units, using big data topic modeling. First, some context. So in 2011, 27% of hospital stays were actually ICU stays. And this actually cost in total 47% of all the medical charges in 2011. So it is very important to manage those ICUs and to be better at predicting the outcomes of each stay. So now EMRs are very widely used, as you can know, but the free text notes that are actually in those EMRs, which are all the notes that the medical staff writes about the patients, are not used a lot. These free notes contain very important and specific information about the patient. So Gassamy showed in his paper that using these text-free notes actually improves the mortality prediction a lot in the ICU patients. He applied his method to the MIMIC-2 dataset. So this dataset is big, and Gassamy's work is great in a way that it has an accuracy of about 90%. However, it is not scalable, and the number of EMRs of ICU stays can increase in the next years and will increase. So it was very important to have a scalable implementation of his work. And this is what this project is about. It's about producing all the steps in a big data environment, which in this case is Spark and Scala. So here is the overall flow. So first we extract the data from MIMIC-2. It was done using the VM and PostgreSQL. Then we selected the patients like in the work of Gassamy. So we selected only the patients who were over 18 and only the first ICU stays. Starting from that, we have the structured features like the gender, the age. So a smaller feature matrix were constructed. And then there are the notes. So the notes are a very specific kind of attributes because they are very long strings and they are very specific, and they need to be pre-processed before actually filtering them, then applying latent direct allocation to construct topics, and then construct the final feature matrix on which we will apply SVM. So as I said, the notes contain new lines and special characters, which made the CSV files of notes completely unreadable to Spark. So first, I pre-processed the data with Java by getting rid of all the special characters and the new lines. Once the CSV file was actually readable, so the notes were grouped by time slots. So we don't have for each entry a patient and one note, but a patient and a list of notes, and each notes were basically written in a 12-hour time slot. This is a method directly used in Gassamy's work. So once we have these group notes, the 500 most important words were selected in order to reduce the overall vocabulary, and then topics were constructed using LDA. So some statistics: there are about 30,000 patients who are over 18 years old. When we only select the ICU stays, we get 21,000 first ICU stay, and a total number of notes of 175,000 after actually filtering the notes that concern discharge or that are too small, considering the number of words. So unfortunately, although the pre-processing of the data was successful, the feature construction was successful too for the structured attributes, there were issues with selecting the 500 important topics and also with implementing LDA on Spark. So I couldn't complete the whole work of Gassamy on big data tools and show an actual result of accuracy. However, the paper can be used to start working on this project, which is really interesting and could be of a big importance. I will probably continue to work on this after the end of the semester. Thank you.